Hey guys, this is video 15.2. We're now going to break down these next three videos, each kind of class of organic compounds and molecules. And these are kind of directly from table Q in your reference table. So if you have those out, that's a huge help and resource. So make sure you have your reference table flipped open to table Q. So this first one is talking about alkanes. Now remember, these are saturated, and that's a term you need to know. That means they are all single bonds. Okay, all single bonds. And we're actually going to rewrite that in just a minute. So where alkanes come into play, guys, they are used as burning fuels. So something like propane, which, you know, if you have a grill or maybe you heat your house with propane, or butane, like a butane torch, octane, like it's in gasoline. They release energy because they store a lot of energy. Okay. So they hold a lot about. They end in ane. That's the big thing you want to remember. That's going to be able to help you distinguish between an alkane, an alkene, and alkyne is that ending. Okay, alkanes. All right, they have the general formula CnH2n plus 2. That's how we're going to figure out the numbers of carbons and hydrogens, but also that ending ane. So kind of using both of those two features. And again, you have this all in table Q, so make sure you know where to look. Okay, it's not that you have to memorize it, you've just got to get some practice being familiar with it for your regions. These are saturated, like we said already. All right, that means they are all single bonds. Very unique of alkanes. All right, maximum number of hydrogens bonded to their carbon chains. General formula, like I said already, of CnH2n plus 2. And guys, N equals the number of carbons. All right, so pentane, that prefix pent, 5 carbons, right? So then we plug it in. 2 times 5 plus 2, that's how we get 12. And then this would be the structural formula for pentane, okay? So what we're going to be dealing with in naming and kind of drawing these structures, we have straight chain alkanes and we have branched alkanes. Okay, these are also referred to as N-alkanes, which is kind of like normal. So N-hexane, it just means normal hexane, where it's all in a straight line. Okay, where there's nothing hanging off of that. So straight just means, hey, all your carbons are back to back to back to back to back, and so on. They're not coming off of each other. So a general rule for naming straight chain alkanes, we're going to use our prefix to tell how many carbon atoms we have, and then add the suffix ane. So again, table P, you don't have to memorize those organic prefixes. They're there for you. So take a look here. We have two ways that we can draw organic structures. You're going to see me kind of do both. I've been doing organic chemistry, guys, now for a while, right? I've taken, you know, oh boy, 3-4 semesters of organic chemistry. How much of it do I remember? That's another story. You may know people who are taking organic chemistry in college. This is not true organic chemistry, okay? This is like day one stuff. All the stuff that we're talking about in this unit is kind of like maybe the first week. All right, so like 2 or 3 lectures in organic chemistry. So don't tell somebody, hey, organic chemistry is super easy, because it's not. All right, it's super difficult. But two ways that we can draw these. You'll see me kind of interchange. I'm going to try to do more of this to show you guys at the level we're at in this class, showing you how things are going together to show all the carbons and hydrogens. But guys, if you just see me draw straight lines, wherever there's a bend or an end, that means that there are carbons there and there are hydrogens hanging off of it. So if you see me just draw empty lines, okay, like so, that means those are hydrogens at the end. A lot of times if you think, oh man, I got to write a lot of hydrogens, okay, so there's a few different ways that you can draw organic structures. Just know that, hey, it can either be like the one on the right, showing all of the carbons and hydrogens. You guys should be drawing it that way, all right? You're not experts in this. You're not going to be experts by the end of this unit. It's basics, so you should be drawing everything and showing it. But you may see me draw some lines, and again, wherever there's a bend in a line, I'm going to try my best not to kind of go back to the basics and show you guys that. Now, branched alkanes, that means they're not a straight continuous line. Okay, they have smaller branches coming off longer continuous chains. Okay, so how do you tell if it's branched You can't run your finger all along the carbons in one sweep. All right, you hit a dead end. All right, so if I did this here, if I went like, oh, okay, one sweep, oh, I can't hit all the carbons there because I have to go back. Oh, I can't hit them all that way because, again, there's that piece. So that you can't just take it all in one like this, or say something like this, because there's still another carbon that you can't hit. All right, that's one easy way to tell. Now, warning, some molecules may appear to be branched, but they're not. So it's always a good habit, guys, to take your pencil, all right, and kind of draw through to kind of say, hey, where's my longest chain? Like this, it looks like it might be branched because the way the hydrogens are coming off, but when I take it and connect my carbons, again, that's what we're looking at, is connecting carbons, not the hydrogens. We're not as much worried about those. But if I can draw one line connecting all of them, I don't have any branches. Branches will be harder to name, okay? They will be more difficult to name. So if we take a look here at this guy down here, the first place you want to start is, okay, look and see how many carbons, the longest chain you have. Well, I have 1, 2, 3, 4, 5. So 5, C5, and how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That follows our formula of 2N plus 2, so we would call this pent for the 5 carbons, ane, because we don't have any double bonds or triple bonds. We have nothing but single bonds. All right. So let's take a look at these examples here, naming some branch chains. It's very, very easy, much easier to write the names of straight chain alkanes, and that's the example we just did. You just count up how many carbons and figure out the formula, bam, and you just change the ending. However, when we're naming branched ones, it's a little bit different. Okay, first step, locate the longest possible carbon chain. That's what we call the parent chain. Okay, any carbons coming off this chain are the branches. So we're going to number the carbons so that the parent chain so that the branches fall in the lowest possible number. Okay, you'll see what I mean in just a second. Name the branches first, separately in alphabetical order as per their prefix, along with the number of carbon they're on. So the prefix, again, is based on the number of carbons. Suffix, we make it -il. Okay, look at that. So again, as we go through and do some practice with these 6 examples here, you'll see what I mean. Branches are named separately unless there are 2 of the same. If this is the case, you lump them into the same branch name with the number, location, and add the appropriate prefix, di, tri, tetra, and so on, depending on how many carbons are in the branch. The parent chain is stated last. That's the big thing, guys. Parent is last in the name, and the number of carbons in the parent chain should agree with the prefix in the last word of the chemical name. So let's just jump in and do some examples here together, okay? So, first things first, I'm going to try to see, oh, is it branched or is it straight? Well, notice how I connected as many carbons. I still have another carbon, so we know it's branched. So once we know it's a branch versus a straight chain, we got to start naming branches. So we're going to label our carbons so that the branch right here, this guy, is in the least number. So if I started on this side, by the time I get over here, guys, this would be carbon 1, 2, 3, 4, 5, 6. That's not the smallest possible option. If I start over here, 1, 2, or 1, 2, doesn't matter. These are going to be in the same spot either way. All right, so if I say 1, 2, 3, 4, 5, 6, 7, all right, that means this guy, this is my branch. Okay, it's on the second one. So we're going to start with the number of the carbon that the branch is coming off of. So this is going to be 2, using a dash next. Now, name this branch. Well, how many carbons do I have? I've got 1. My prefix for 1 carbon is meth. Okay. Notice here, step 2, the branches, we put the prefix -il, or excuse me, the suffix -il at the end. So this is 2-methyl. Then I'm going to name the rest of my chain. So 1, 2, 3, I've got 7. So my prefix for 7 is heptane. This is called 2-methyl heptane. 2-methylheptane. And guys, again, the biggest thing you got to remember is how do I name a branch? So I've got to name my number my carbons first. Then I'm going to just go through that, and then the branches end in -il. The main long parent chain ends in ane because these are alkanes, right? They're all single bonds. So take a look at example number 2. It's going to take practice. You got to practice this. You're going to see a couple organic molecules on the exam that you're going to have to name or identify functional groups, so you've got to commit some time to this. All right, so this has been labeled for me. Look at the red, right? How long it is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I'm going to name all those other chains. So take a look. I've got a 2-carbon chain here. I've got a 1-carbon and a 1-carbon there. So when we have multiple branches, we're going to alphabetical order. So name them first. So this would be a meth. This would be a meth. This would be eth, because there's 2, right? That's our prefix for 2, eth. So we're going to start with the eth. So again, look at the number we have, the number of the parent chain. So this is 3-ethyl. Now we have 2 meths, okay? So this is where it's saying, okay, if you have multiple that are the same branch, we're going to lump them together with their number locations and add the appropriate prefix. So this is going to be carbon 4, carbon 7, so 4, 7. How many meths do I have? I have 2. So this is 4, 7 dimethyl. And then the last one is going to be naming that long chain. There's 9. That's a prefix of non-ane. This is a long one. Do I anticipate you seeing one like this on the Regents? No, but you could, okay? You could see something like that. So 3-ethyl, 4,7 dimethyl nonane, or nonane, however you want to pronounce it, tomato, tomato. So if you feel kind of comfortable, guys, you've seen a couple examples, pause the video, try to do these next ones. Again, you may be confused. This is confusing. We're trying to just get you as much information as possible and know how to use your tables to help you with this, okay? So example 3, find your longest chain. That's this middle guy right here. You can kind of see it. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to name these 1, 2, 3, 4, 5, 6, 7, 8 carbons. Remember, wherever there's a bend, that's a carbon. All right. So that's my big chain. So now I'm going to label, oh, look, there's 1 carbon here and 1 carbon. So they're both methyl. Okay. So we've got it on position 3 and 4, dimethyl. And then the long chain is 8, so that's octane. Okay, octane. Let's look at example number 4. It does label them for you, so it doesn't matter which one you start with. 1, 2, 3, 4, 5, 6, 7. There's my long chain, longest chain. So I've got a methyl coming here, and I've got 2 carbons, so that's ethyl. So I would name this as carbon 3 is where my ethyl is. 3-ethyl. 2-methyl, and then the long chain is heptane. Okay. Example number 5. Count up. So 1, 2, 3, 4, 5, 6, 7, 8. That might be the longest. Check every single one. 1, 2, 3, 4, 5, 6, 7. So it's not going this and down. It's not going this and up. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be one of these last lines. It doesn't matter which one you choose. That's the same as this as well. Okay. So we know that's our long chain. Now start looking at the other ones. All right. So we've got 2 carbons here, 2 carbons here. So I'm going to label them. Okay, 1, 2, 3, 4, 5, 6, 7, 8, because that's where my branches are going to be in the lowest number carbon coming off of. Okay, so now we're going to label them. So ethyl comes first. So I've got an ethyl on 3 and 4. So this is going to be 3,4 diethyl, 4-methyl. We got that other methyl hanging off right there. And then my long chain is 8, octane. Okay. 3,4 diethyl, 4-methyl octane. All right, last one here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So these two are the same. 1, 2, 3, 4, 5, 6, 7, 8. Nope. Okay, so now those 7s aren't the longest, but you can kind of see where it is, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This guy right here is our longest. So now you've got to think, okay, where's going to be the least number? So starting, guys, right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now there's my main chain. I got a methyl hanging off here, I've got a methyl right here, and I've got an ethyl right here. So this is going to be 6 ethyl, and then I've got 2 methyls, so it's going to be 4, 5 dimethyl, and then decane. Okay? This takes practice, guys. You've got to put some time in. Again, using the prefixes, table P and table Q are going to be your biggest helps. All right? Last thing I want to point out, guys, these rules, IUPAC. We've heard that term. We've seen it a little bit. That's just the international rules for naming, all right, in applied chemistry. So just if you see that term, what's the IUPAC name? It's just, hey, how would you name this? What's the appropriate way to name this? So those are alkanes. In the next video, we will start talking about the next type of series.